In this video, I will be explaining this example. Typing errors in a text are either non-word errors or word errors that result in a real but incorrect word. Spell checking software will catch non-word errors but not word errors. Human proofreaders catch 70% of word errors. You ask a fellow student to proofread an essay in which you have deliberately made 10 word errors. First one, if x is the number of word errors missed, what is the distribution of x? Let me just write down first. 1. X is the number of word errors missed. So I write down x is number of word errors missed. I say just missed. Then how do we find the distribution? Here there are two outcomes, missed and catch. Therefore, this might be a binomial distribution. You know already conditions. What are the four conditions of the binomial? N should be identical. Yes, here we know we use 10 word errors. Therefore, n equal 10. So first one is satisfied. Then second one, how many outcomes? Two outcomes. There are two outcomes. Yes, the catch or missed. Here catch or miss. Therefore, second one is also satisfied. Third one, trials are independent. Yes, this is independent. So this is student, they are independent. Right. How about the fourth one? The success probability. Okay, success probability we use P. So what is the success probability here? We use X for the missed, right? Therefore, success probability should be the probability of miss. Now you see catch 70%. If they catch 70%, then what is the percentage of miss? 30%. How do you find it? 100 minus 70, that is 30%. So, probability is 0.3. All four conditions are satisfied. Therefore, we can say x has binomial distribution n equal 10, p equal 0.3. Now go to the second one. This is asking why. Why is the number of word errors caught? Right. How do we find it? I say y equal number of cats. Asking what is the distribution of y. First one, for the binomial, first condition. What is that? N. Again here n equal 10 because they check only 10 words. Then outcomes, yes, catch or miss. Then the independent or dependent, they are independent. Then the success probability. What is the success probability in this case? Here, y is the random variable, it is the catch. Therefore, we need to consider the probability of catch. It is what? It is 70%. Therefore, it is 0.7. Now we can say y has binomial distribution, n is 10, p is 0.7. Those are the distribution of x and y. Then go to the second one. What is the mean number of errors caught? Yes, I discussed in my last video about mean and variance. Then asking the mean of caught. So what is the catch? It is y. Therefore, mean of y. Mean of y is, you know, it is always NP for the binomial. N is 10, P is 0.7. Therefore, that is 7. Then asking what is the mean number of error missed. Yes, miss is the x. Therefore, mu x equal again np. What is the n? 10. P equal 0.3. That is 3. So that is the mean number of x. Right. The third one. Third one asking what is the standard deviation of the number of errors caught. Okay, number of errors caught, that is the y, right? The standard deviation. Before we find the standard deviation, let me find the variance. Variance of y. What is the variance of y? NP 1 minus P. So here we already know NP, so I write down that 7, then 1 minus P is this, right? So 7 times 1 minus 0.7, 2.1. Right, then we need to find the standard deviation. How do we find the standard deviation? Is square root of the variance. So 2.1 square root is 1.45. Those are the mean, variance and standard deviation of the error code. Right, then go to the miss. They are asking actually what is the standard deviation of the number of error missed. Right, first let me find the variance of y. It is again np 1 minus p. So this equal np equal 3 here, 1 minus 0.3. So that is 2.1, and standard deviation is square root of variance, therefore this is 1.45. You see, variance of both x and y are the same. Why? Because x is the opposite of y and y is the opposite of x. In this type of situation, you will get the same variance and same standard deviation as well.